Hey everyone, it is time for another recitation. This one is purely a bonus. I just wanted to show a brief intro to writing a Node-Express server, which learn all of this in backend anyway, but I had a lot of people ask me, and I think having a little bit of knowledge here will help you communicate better with your backend team member during build weeks. Plus, it's neat to know how it works and what these server programs we've been using over the last couple days have been. So, what I have here, I have the Express docs pulled up because if we want to learn something, yes, the training kit is wonderful and the backend training kit is great, but we should always read the first-hand reference material. Read the docs if you want to know how this works. I also have pulled up here a REST client, which is a program that's going to allow me to make my various types of requests outside of a browser. This one is called Insomnia. Another popular one is Postman. You can Google for them and find them and install them if you want to follow along. Otherwise, you could spin up a quick React app and use Axios. But this is going to be a little bit more dynamic for me. So, Insomnia. All right. What I have here on my left side is just an empty folder. Just an empty folder. I'm going to open up my terminal, and I'm going to run a command called yarn init. And this is going to create a package.json for me to define my project with. I don't need to use any fancy create React app like systems here because we're going to have very few dependencies, and that's nice. So, yarn init, it's going to ask me some names like, ask me some questions like the name of the project, the version, the description, which I could leave blank, an entry point, which I'm going to keep as index.js, the repo URL, which I don't need, the author is me, and then this final question, you could also use the -y flag for it to just answer all these questions automatically for you. You've seen before a warning that says package.json doesn't have a license field. And that's a warning. That's not an error. It won't cause anything to go wrong. But when we make our code available on GitHub, we need to specify what people are going to be able to do with it. If we don't have a license, then yes, we've made our code publicly available, but legally, people that want to read our code and perhaps use it, fork it, modify it, don't know what rights they have. So there are different types of open source licenses that allow you to specify, yes, I'm publishing my code publicly, but you can only use it for educational purposes, or you can use it for anything, but you have to also make your code open source, or you can use it for anything non-commercial. There's lots of different licenses out there. Some of them stricter than others. Some of them, have those financial clauses in there. And there's some great resources for reading about the different kinds of licenses, even if you're not a lawyer and don't want to read the actual legal content of the said license. The default one that Yarn chooses for me is the MIT license, which is very permissive. It basically says kind of do whatever you want. I'm fine with that. And for a toy project like this, I'm more than happy to license it under MIT, because if any of you all want to use any of this code, you're free to. And I think Lambda actually technically is also free to do whatever they want because I'm doing this on their time. So, I'm going to say that. Don't need to mark this as private, and we're done. If I ls here, I now have a package.json, which we're going to take a peek inside of, and it just has everything that I've written here. That's it. What we want to do now is start up our project. So what I'm going to do is I'm going to do yarn add express, because that's what we're going to need to write our server. And technically this is the only dependency that we're going to need. We're going to add one or two more as we get further in, but that's it. 6-second yarn install. That's pretty cool. And so now if we refresh my view of the package.json, we'll see that I now have express added as a dependency. And I also have my node modules file, just like in a React project. This is still just JavaScript. So What I'm going to do now is I'm going to create a file called index.js. You could also call this server.js. It's really our choice for what we want to call this. And this is where I'm going to define my, my server. Unfortunately, we cannot use the import syntax here. When we run the code that we're doing with React, we're using a slightly different version of JavaScript than the one that Node, which is the command line interpreter for JavaScript, uses. If you want the import syntax in Node, it's coming. You can always harass Dan about it because Dan is a contributor to the Node project. Instead of import, we use a syntax called require. So I want to require the Express package, and I'm going to name it Express and put it into that variable. And that's how we do imports with Node. From here, I define my server, and I do this by running the Express package that I imported. And then I need to set my server up to start. We do that by running a method on the server called listen. It takes a port that you want the server to run on. Let's do 4040. And then a callback function of code that you want to run when the server starts listening. I'm going to add a console log and just say server started on port 4040. Now to run this file, we need to execute the JavaScript inside of index.js. And we can do that by running the command node index.js. And there we go. Our server's running. But it doesn't really do anything. And I also don't want to have to type node index.js every time. So what I'm going to do is I'm going to add a script to my package.json. We do this by adding another field to our JSON file called scripts. And this is going to be equal to an object. And in here we define the key names of our scripts. I'm going to call this one start. And it is going to run node index.js. And if I had decided to call this file server.js, I would just change it to node server.js. And now, instead of doing node index.js, I can just say yarn start, and now it will run the command node index.js for me and start up my server. But right now, my server does nothing. It starts, it listens on port 4040, but it doesn't do anything. We can test this out in our browser. I can go to localhost 4040, and we get the error that's given people so much trouble and confusion over the past projects, where it says cannot get slash. Uh-oh, looks like an error. And it is, but it's also not. What this is telling us is that the server that I've defined here doesn't return anything when I try to get the root. In the same way that if I went to /test, there's nothing to get there. And when our browser tries to access a website, what it's doing is it's making a GET request for the HTML on that page. We can handle these requests by using Express. I can say server.get and then give it the path that I want to handle. So I want to handle a request that comes in at our root path. I could also handle test. I'm going to keep it like this. And then we'd give as the second argument a callback function that takes two arguments. An object that contains the request the client has sent us, and then an object that allows us to define the response that we want to send back. So I can console log the request, and I can also send back a response. Response has a method called send, and this is going to let me send back whatever I want. I'm just going to say hello world. It's our classic example. So now I'm going to need to restart my server so it picks up these changes. And let's refresh our web browser. We see that I'm getting back the text hello world. when we make a GET request to slash. Oop. And we also console logged the request object, and there's a ton of stuff in here. And I would refer you to the Express documentation if you want to read all about what you can do with this request object. And we'll get into a little bit of that as well. So notice how this is showing up as text here. Watch this. Let me restart my server. Now if I inspect this, we'll see that it is hello world inside of an H1 tag. And that's how websites work, is a server is set up, and when you make requests to it, it parses them and then sends you back a string that is the HTML of your page, or some JSON, or whatever. And that's how all this works. And we can look at what a request is under the hood. So there's a command that I think you should have installed on Macs automatically. I don't know if it comes with Git Bash or not, but it's called curl, and it's kind of the Swiss Army knife for making network requests. So I'm going to run the command curl -- verbose, and I'm going to make a request to my server, localhost :4040 /, and we see here where we have our right carets. This is the request that I'm sending. It's a GET request. The protocol is HTTP. I'm sending it to this place. My user agent is identifying what program I'm using to make this request. And then we have this accept header, which tells us what format we want our response to be in. We could specify, for example, that we want JSON here. Curl is accepting anything. This is the response that our server sends back. HTTP, the code is 200, and that means OK. We can see the server is Express, the content type is HTML, and the actual content is that H1 that we sent in. And so what Express is doing for us is we could get this request, which is a string with this contents, and parse it ourselves and figure out the response we want to send back, which would be a string correctly formatted in the same way, but that's a lot of work. What Express allows us to do is use an existing bit of code that is going to parse the request, route it to however we want to handle it, and then send back a correctly formatted response. If I want to send back JSON, I'm absolutely allowed to do that. And instead, I can do response.json, and I'm going to make this be, let's do an object with a key name of person and a value of me. And now, I'm going to restart my server so it picks up the changes. When I refresh the page, this time I get back a JSON object. And Express is nice enough to give us this method, JSON, in order to send back a JSON that we want as a JSON stringified string, which we then parse, and Axios parses for us when we make that request. But we can send anything we want back. Plain strings, HTML strings, JSON strings. It's all a string at the end of the day. There's lots of different formats that we can both send and receive from the server. JSON is kind of the default here, but more than likely you'll run into others over the course of your experience as a developer. So, do we have any questions so far?
Why don't you just install NodeMon so you don't have to keep restarting the server?
Yep, that was going to be the next thing that I do.
Okay.
Yeah. All right. Any other questions? All right. Cool. So yeah, like it was pointed out, restarting this server manually is annoying, and I want that experience that I have when developing React, where it auto restarts for me. We can do that by adding a dependency called NodeMon. So I'm going to do yarn add -- dev NodeMon, which I don't know if it's pronounced NodeMon or NodeDemon, because that is both readings of that word. We're going to install this, and then we'll just change our script to, instead of it being node index.js, we'll make it nodemon index.js. And that will handle watching all the files in this directory, and when it sees them change, it will restart our server. So now when I do yarn start, it's going to run the command nodemon index.js, and if I make a change to any one of these files, say index.js, we can see it automatically restarts the server for us. And so let's build out basically the Friends application here. You'll learn in backend how to use databases so that your data can persist between instances of your server. Because right now we're just going to keep everything in memory, and then whenever our server restarts, we're going to lose all the changes that we had. And databases allow us to keep those in a format somewhere on a disk, and we're going to learn about relational databases, which allow us to search and request data in a very efficient way.
Real quick, Henry, the right half of your screen,
Yes.
the bottom, the top half of that, how do you have it so it's got JSON raw data headers?
Oh, that's just Firefox. That's what Firefox does when you
When you just give it JSON.
Yeah, when you get JSON, it automatically does this. There are extensions for Chrome that will allow you to have the same thing, but Firefox does this by default. You'll see this raw data if you were to go here in Chrome.
Okay, thank you.
Yeah. All right, cool. So I'm going to make a friends array. Let's do name, Henry, name. Let's get Bard in there. And then who else do we want in here? Let's get my mom. Do Bard and Joe. Okay. And so now I can send back as a response to the, let's do API/friends like we did yesterday. I'm going to send back, I'm going to stop console logging the request, and I'm going to send back as JSON the friends array. So now I cannot get slash because I'm no longer doing anything at that endpoint, but if I go over to API friends, then we'll see that I forgot to make these individual objects. So let's do that real fast. Oop. And there we go. Okay. So now when we refresh, we get back this array that contains those 3 objects in there. Those are all of our friends. And we can also accept other types of requests. So instead, I want to handle the post on /API/friends. And here, we're going to take in the request and the response object, which we usually abbreviate as rec and res to save us a little bit of typing. And now we're going to have to deal with the input. Right? When we send data along with our post request in Axios, I'm going to need to have access to that. And we generally send that input along as JSON. And I don't want to spin up a React project with Axios or anything, so I'm going to use this REST client, Insomnia. I'm going to add a new request, and I'm going to call it post friends. And here I just get to define my request. I want it to be a post request. I want it to go to http://localhost 4040/ API/friends. I want to add a body that is of type JSON. And let's add a friend with a name of Charlie. And notice we have to use actual JSON formatting here. It's not like our JavaScript object where we can play fast and loose. JSON is a strict standard. For example, you cannot have a trailing comma if you don't have another line following it. And keys have to be strings. But now I can post this endpoint and see what happens. And right now I'm not sending a response back. But we can do this. We can send back a response. Let's send back a response, and I'll send back the friends array. So we can see when I post this endpoint, I now get this array back, but I'm not doing anything with it. That's because these verbs get, post, put, and delete, they help us say what kind of action we want to perform, but it's entirely up to the server to choose how it carries that out and what data it decides to send back for us. And I also want to get the body of this request. And we're going to find that within request.body in a minute. If we try to do this and we check our console log of the body, we're going to see it's undefined. The body is normally where the data that we send along with our Axios request in a post or a put would live, but it's not here by default. And that's because all of our HTTP requests are just strings. And Express by default does not make any assumptions about what the request format looks like. If that request is formatted like JSON, then we need to tell Express, hey, I want you to parse that request body into a JSON object for me to use, and we do that with something called middleware. So just like Redux, whenever we dispatch an action, we can use middleware that will take a look at that action and decide what to do with it before it actually reaches our reducer. With Express, we have middleware that's going to take a look at our requests and decide what we want to do with them, how to modify them, to reject them or not, before they get sent to our actual handlers for the get and the post. So I'm going to do server.use, and Express has this built in. It's express.json. And this is how we apply middleware, with server.use, and then we give it the middleware we want as an argument. Now, with this added, when I send my post request, we'll see that the request object.body is now what I had here. And so what we can do is we can modify our friends array. I'm going to do friends.push, and I'm going to add the request.body, and now I'm going to return the modified friends array, and that is our very, very basic post request. When I send this, we see I accidentally hit it twice. Now we have two Charlies. And that's a very simple way to handle a post request. Do we have any questions here? No questions? Okay. So let's add some IDs in here. ID of 1, ID of 2, and ID of 3. And we're going to define a variable that holds our next ID in it, and that's going to be 4. And what we'll do when we push this is I'm going to define a variable called friend. Oh, did Zoom mute itself again? No. My audio seems correct. Could anyone else hear Amir when he asked his question? Let's see. Okay. Amir, I think you might have been muted then. What was your question? Okay. While Amir's typing, I'm going to make this new friend object. So I'm going to spread the request.body, and I'm going to add an ID, and it's going to be my next ID incremented by 1. Normally this would be handled by a database. We're just kind of doing it for fakes here. So now when I send this request, oh, I made this a const. This should be a let. Now when we do our post request, we see we get that not pushing our friend to the array. So let's fix that. Okay. now we get our friend with the ID on the end. Okay, so Amir asks, the middleware express.json is used to convert JSON into JavaScript objects for all request objects. Close. What it's going to do is with our request, it will see if the body is of the type JSON. And JSON, the actual JSON format, it is a string. It is a string representation of our JavaScript objects. And if we wanted to transform a JSON string into a JavaScript object, we would have to do json.parse, and that's basically what the middleware does. It checks and sees what the type of the request body is, and if it is of type JSON, it will parse that string into a JavaScript object and put it on request.body. There is probably a key on the request for you to see the unparsed body. I just don't know what it is off the top of my head. But we're basically always going to be adding this line here because we're going to be communicating with our APIs via JSON and not some other form of serialization format like XML or EDN or any of the other ones. Yeah, so now I have my friends added here. And this is where we can also use the slugs, the parameters inside of our routes. So just like we would with a React router, I can set up a handler to listen on API friends /:ID. And when I do this, let me get this out of the way. When I do this, there will now be request.params, and it will contain this ID like we have with React Router. For now, I'm just going to return that entire friends object, but we'll fix that. So if I perform a GET request against friends/1, we'll see that when we console log request.params, similar to match.params, we get an object with ID equal to 1. So I could save my ID to be equal to request.params.id, and then I can find the friend by doing friends.find, and I want to get the friend object, and I want to check and see if the friend.id is equal to the ID that we got from our request parameters. Notice that I'm using double equals here. That's because this request parameter is a string, but the IDs I have here are numbers. Double equals will do type conversions when checking for equality. So if I spin up a node REPL real fast, we can see that 1 obviously does not triple equal the string 1. They're not the same. But 1 does double equal the string 1 because it'll convert the types. And this can do really weird things, and generally we want to avoid double equals unless we need to rely on its type converting behavior. Alright, so that's going to find our friend, and we're going to return our friend. So when I get friends/1, there we go, it returns me, and we can get friend-2. And we wouldn't need this body anymore, and Axios wouldn't let us add one, but technically you could send bodies with a GET request. It's just bad form. And what if we try to get a friend that doesn't exist? We get nothing back. This is where we would make use of our status codes. When I do this JSON, it's implicitly going to return a status with the status code 200. So I want to check. If friend is truthy, then I want to send back a response with the JSON in it. Otherwise, I'm going to send back a response with a status code set to 400, which our 400 errors mean a client made the error in their request. I'm going to actually make it 404 because that is the 400 error for when you try to request something that doesn't exist. And I am going to give back some JSON that has a message in it that says friend with ID does not exist. And so now, when we try to make our request for a non-existent friend, we get 404 not found, and we get our message. All right. Do we have any questions here? No questions? We're all feeling good about this? No questions because it's understandable, or no questions because you're lost?
I've done it already. I understand it.
Okay, cool. What about the new folk in the audience?
So far, it's understandable.
Okay.
I think it's just JavaScript, so yeah.
There's a lot going on in here, but I want to kind of set you up to be able to read some of this. So another thing we can do is, instead of writing all of this in our main file, we can split up where we define these different routes. And so what I'm going to do is I'm going to split my screen and kind of minify this terminal down here. I'm going to create a directory called routes, and I'm going to create a file in here called friends.js. And this is where I'm going to put all of the routes for my friends, because I might have routes for friends, for books, for water parks, for whatever type of entities my API is dealing with. And in here, we are going to require the express module. So express is equal to require express. And then I am going to create a router. And we do that by calling express.capitalRouter. And what this allows us to do is basically define a mini server, just with the routes that we want on it. I'm going to take all of the routes that I defined up here, and I'm going to plop them in here. But I'm going to replace all the references to server with a reference to my router. And I'm also going to change the URLs that these handle. Instead of this handling friends, this is going to handle /. Because when I add this router to my server, I'll specify the endpoint that all of these routes are working off of. So I don't have to put API friends for each one of these. And now I need to export this. Just like we don't have access to our imports, we can't do export and export default. Instead, we do module.exports, and we set that equal to the thing we want to export, which is going to be our router. Now, within our index.js or our server.js or whatever we want to call it, I can require this. So I'm going to say const friends router. It's going to require /routes/friends. And then I want to add it as a set of routes to my server. And we do that with server.use. And we specify the route we want to add this on. This is going to be API/friends. And this is going to use the friends router, because our routers are technically middleware. They just stop the request. I'm also going to need to move these variables that I defined into here. And now everything is going to work exactly the way it did, but we're allowed to use this kind of multi-file organization, where we can define routes specific to our friends in here, and then hook them up to our API under the same banner, essentially. Any questions with that? I know that's a lot of new syntax with the requires and the module exports and the uses, but just want to give you an overview. You are going to actually learn all of this in backend, so.
So in the friends router, you just kept what's that sign? Slashes, but then here in server.use API.friends, that's what's going to be applied to all of those.
Yeah, so this is going to get prepended to whatever route I have here. So this is going to work on API/friends This is going to work on /API/friends/some ID. We could add, you know, another route, like router.get /test. And I'm just going to return some dummy data back. I'm going to do res.send and send a string. And now if we make a GET request to /API/friends/test, oh, that is getting got by this ID. I think I would need to move this above this. Yeah, there we go. Now we get our dummy data back. So whatever we put here when we apply the router is going to get added before whatever routes we were using inside of the router. And we would be able to do the same thing with put requests and also deletes. And we would just have to write the code of how we want to handle that and the data that we want to send back. For example, it's very common, and we're going to see in the afternoon project today, that our post request does not send back the entire array of data. Instead, it usually just sends back the new object that we've created. So when I post API friends and I give it Charlie, it's just going to give me back this object that has now been created on the server. And you'll have to figure out how to either add that to your state or re-trigger another GET request to get the updated array or whatever of data.
Is there a specific reason why would you choose not sending back the whole data?
Yeah, and that's because it's more data. It adds overhead to the request. We're working here at pretty small scales worth of data, but for example, with the shop that Dustin had, if he wanted to return whenever you put or post a new thing, he would have to return the 20 or so shop items. And what if there were a lot more, like Amazon, or even a smaller store, like, what's a medium-sized store? J.Crew. That's where this t-shirt is from. They'd have to send back potentially hundreds and hundreds of items. And most of the time, when our requests get that big, we would actually split it up into pages, like we saw with the Star Wars API. You would get the first set of characters, and if you wanted more, you would have to request additional pages. Where would the post add it? To which page? Which page we want to send back? Like, it's starting to get complicated. So instead, the server usually is just going to send back the object you created, and you'll have to either figure out where you want to put it into your local state, or perform another GET request on the section of data that you wanted to see if your modification or addition modified that set of data. Network requests aren't free. They take time. They take bandwidth. The ones we're doing right now are small and fast, but it doesn't always get to be the case. All right. Any other questions here? No questions? Come on, we have 5 minutes left. This was just meant to be a brief overview. I'm sure you actually have questions of, you know, how we would do these things and hook up to databases and best practices and other stuff we can do with our request and response objects. And you'll see that on backend. I just wanted to give you a little preview so you could maybe understand what's going on in the Movies API that we're looking at today.
Henry, can you hear me?
I can.
Okay, yeah, so I was just trying to practice using Connect to set up a database, and I sent you a message about it. I'm still getting the error that I add the connect. I cannot do a connect init because it's not installed locally.
Yes.
So
Did you use npx next in it?
I did.
Okay, that should work. And if it's not working, then there's probably some environment issues that are preventing it. Like you have file names that have colons or slashes in them, or your path variable is configured incorrectly. I can take a look at that offline if you'd like.
Okay. Sure.
Sorry, it's just probably a really specific question. Yeah. So this is it. This is what backend development is. It gets a lot more complicated when you add databases and other services and all these things, but getting started is just a smidge easier than setting up a React app and learning all this new syntax. You just kind of accept the routes and send back responses, and you get to choose what all those things mean. The last thing that I wanted to show you is that I'm allowed to make these requests in Insomnia, but if I tried to do it in my browser, I would get a CORS error because I'm trying to request from a different origin. The way we fix that is on our command line, we add a dependency called CORS. So I'm going to do yarn add CORS. And then we require it and apply it as middleware. So const CORS require CORS. And then I'm going to add it as middleware. Oop, this is in the wrong file. I should be up here. So I'm going to require CORS, and then just like we applied express.json, server.use CORS. And now you'll be able to make requests to this API from web browsers. And there you go. Oh. Why didn't it like that? I spelled require very wrong. There we go. All right. And that's really all you need to get started writing these things. Feel free to look ahead in the training kit if you're interested in this stuff, and ask me any questions that you have as they come up. So, unless there's any final questions, I think that's it for today. Just wanted to make it kind of brief and give you a peek ahead. So, I see Ian typing.
Thank you, Henry.
Oh, you're welcome. All right. Thank you all so much for coming. I'll be doing a recitation after stand-up ends at around 5 Lambda time about today's project. So I'll see you all there.